Hi everybody. Today I want to share with you probably my favorite Ghidra script that I developed. This script is going to dramatically increase your ability to perform static malware analysis. It's going to do this by automatically renaming unknown functions with the preview of the included capabilities. This will allow you to, at a glance, statically look at a file and determine if a function is relevant to an indicator compromise and you want to dig into it further, or if it's probably a background utility function that you want to just skip over. Additionally, the context can really help you decide if the function you're looking at is the only location an IOC occurs at, or if there may be backup locations that you want to read for more completeness. Finally, that context really does make it easier to identify unknown library functions as well. We're going to start the video off with just a little bit of the background of how the script works and how you read the naming convention, and then we're going to apply the script to a malicious rat to really demonstrate how the script can aid in your malware analysis efforts. To start with, let's go into the script. So the script, when you think about why we created the script, you might have to think about what static analysis really entails. And basically, static analysis is depending on knowing where to look and where to avoid. So APIs provide the biggest clue of the capability and thus the IOC location. So the goal of the script was to preview capabilities in a feasible manner. I've seen some scripts years ago that tried to do this, but they ended up labeling like every API it found for the function name, and it just became unwieldy, and it didn't really add any value because you almost got lost in the noise. So the part that really works well with this script is it has a compact naming convention that lets you preview the general capabilities at a glance without overwhelming you with information. So to begin with, we're going to open up the script, and this script is from my GitHub page. It's the link's listed in the description, so you can download it to play with on your own. We're going to go ahead and open this up to review, and we're going to go over basically how the script works in naming convention. The script generally works by it reviewing all the instructions and it looks for call instructions, and then it pulls out the API of the call and compares this to a list of important functions that I identified for different capabilities. If it's found, it basically tags that function name with either a capability and a category for that function, and we'll go over what those are. That means you get a kind of a shorthand naming convention of the capability based on the different APIs. So they get grouped into categories and then grouped into capabilities. The other benefit of the script is it not only finds all the capabilities within a given function, but it does it for all the children function inside that tree hierarchy, and it basically bubbles them up to the top. So that means you can look at a function, determine what's inside the function, what's in children functions. It really saves you having to dig down, dozens of different functions to figure out what a top level function performs. Alright, so let's go down to the naming convention. So if you open the script at the very top, they have basically the usage statement that gives you some more information about it. So our naming convention here starts here. So basically all the functions that this script names are going to start with this f_p double underscore. That identifies that the lip was, or that the function was auto-named with the preview of the capabilities. If you run this function more than once, the name will be updated. So the function will only be renamed if it starts either with the Ghidra default function name, that's the fun underscore, or the script's default function name, that's this f_p. If any other name is identified, it assumes it was either a library signature that named it that you don't want to change, or that you manually renamed it and you don't want to change it. So that way, when it finds the preview default name, it'll update it. So let's say you run this script and then you find some dynamically resolved APIs that you're stored in D words. If you rename those D words with the case sensitive API name and then rerun the script, it will propagate those changes up through all the automatically renamed functions. But again, if you change the preview or the prefix to something specific for you, it won't update those names because it'll assume that you knew what the function did, and it won't override it. So the P is just for preview capabilities. The F is because I start all my functions with f double underscore, and that way when I sort them alphabetically, I can get a concise list of everything I renamed, and so that way it really helps me find the manually named functions. Because a lot of times I know the general category, I know I named a crypto function, but I don't remember the exact name. So the script is going to put a category and a capability. Each category is going to be separated by a double underscore. Within the categories, you'll have an underscore and then the capabilities. This is just done so I can parse it easily with Python. Within those categories, and well, those categories will be things like networking operations, file operations, process operations, service operations, and so on. There'll be a category. Each category, or sorry, within that category, you'll have a specific capability. That capability is generally identified by a single preview letter. That preview letter is going to most of the time be the first letter of the name that makes sense. So for instance, if the category is networking and you have an R for the capability, that R is for receive. If you have an S, it's for send. If you have the file category, the R wouldn't be for receive, it would be for write. And so it doesn't take very long to get used to what these preview letters are. If the preview letter is uppercase, it means the capability is found in the current function. If the preview letter is lowercase, it means it was found somewhere in a child function and basically bubbled up to that parent. So you can differentiate what's done in that current function, what's done somewhere down the tree hierarchy. The last entry of the preview name will be the function address. This was done just for Ghidra. If I did this in IDA or a different disassembler, I would have left this off. But Ghidra allows you to have duplicate names, which I'm not sure why they thought this was a good idea, but for reverse engineering, it really hinders your analysis. Because particularly when using a script like this that puts a general naming convention, you'll have a lot of function names that are named the same thing. And when you click on a name in Ghidra or really any other disassembler, and you highlight all the occurrences, they're highlighted just based on a simple string search. That means if you have two functions that had the same general preview capability, but are different functions, they'll both get highlighted. This means there's no way to distinguish if it's the same function called twice, or if it's two different functions called. And that can really change your kind of educated guess that you do when you're doing static analysis. So to account for this in Ghidra, I added the function star address as the very last indicator in the naming convention. So that way every function is named uniquely, even if they have the same general capabilities. So one exception to the naming convention is that the start of a thread. For thread starts, I don't bubble up all the capabilities. All I do is put a category for the thread start. It's going to be TS, because I want to be able to identify thread starts. But threads are basically like little mini programs. So not all the time, but very often, if I put all the capabilities inside a thread, you just get basically every capability, because there's oftentimes so much variety in what a thread does. And it's almost like naming the win main function. It doesn't add a lot of value. So I added a category so I can quickly find where the threads start and review those and name them my own, but I didn't bubble up the capabilities. The last thing to note is the preview letters. If you want to know what APIs they go through specifically, those are all found in the last function of the script, the build new function name. So we're going to do this at the end. We're going to go look at it, and then we'll be able to see what, just an example, what the APIs are for different categories and capabilities. So here's the general categories we have and the capability preview letters. We have TS, that's for the thread start, and there won't be any further preview capabilities there. And then we have the networking category. Within networking, we can build a socket, we can connect out, listen, send, receive, terminate, and modify. The modifier is generally for like htons and then ntos, basically modifying the endiness of usually port or IP numbers. We have the registry category. We can open a handle, read, write, or delete. The file category, again, opens a handle, read, write, delete, copy, move, and enumerate. For the process category, we have the open a handle. We can enumerate processes, create them, terminate them, read and write. We have the service category. This can open a handle, create a service, delete a service, start, read, or write to a service. And then we have the thread category. The thread will create a thread, open, suspend, or resume a thread. Next, we have the string manipulation category, and all we look for here is basically string compares. Next, we have a ZC. This is for zero calls. That means there's literally no calls within the function at all. So oftentimes that's helpful for identifying potential crypto functions or just really utility functions that aren't doing any calls. Because most of your capabilities are performing API calls. If there's no calls, you have a good chance that there's not going to be an indicator of compromise you need to find in there. The final category we have is cross-references, the xref. And here it's just going to have the number of cross-references for that function. So those are all the categories and capabilities. And so again, each category is going to be separated by a double underscore. And within the category, you'll have a single underscore and then the preview letter. uppercase is for inside the function, lowercase is for in a child function. With that, let's go down to the last function and look at a couple of the APIs to get a sense of what they are. You can see here we have the build new function name at the end. And we have this dictionary here. You can see for networking, and we have for networking connect, the C. Anything if we find a connect, internet open, internet connect, internet open URL, and so on, it'll get labeled with a network connect. For network listening, we're looking for bind, listen, and accept. And for send, we have the send to, internet write file, HTTP send request, WSA send to, and so on. You can see how by having one single capability letter, we can get all these different functions that we're watching for. So instead of having some long name where you have send or WSA send, receive, INET address, you'd have a networking or network underscore SRM. So you can see how it really shortens the name, but lets you get an idea of what's going on, because you're generally not going to care that much if it's send, if it's WSA send, if it's the internet write file. You want to know that you're doing a send loop. So just knowing you have some send capability gives you the idea what's going on, and that can help you find where to look. So if I'm looking for IP addresses, I might go for the network and connect functions and find basically where the connect gets the URL or the IP address and backtrack to see where they're derived from. That's how I can quickly find my IOCs statically. That's really everything we need to talk about for the function itself, or for the script itself. So let's go ahead and apply this now and see how it works. For this example we have, I already have it opening up here. The hash is listed in the description. You can download it from malware.com to apply the script and practice on your own. So again, you can get the script from my GitHub page, and you get the malware from malware.com, and all the details are listed in the description of the video. So I'm going to go ahead and apply the script. So I'll hit the script manager. If you're not familiar with how to apply the scripts, I went over this a little bit more detail in the last video with the getting started with Ghidra. But I basically already added my script directory with this little outline symbol. And so it's the AGDC services. And I'm going to select the preview function capabilities and hit the run key or the play button. This will take a little bit of time, maybe anywhere from 30 seconds to a minute to run. It runs a little bit slower on my machine because I have all the video recording software going on and everything else. But basically, because it's going through every instruction, trying to figure out if it's a call, then finding the specific APIs called, and then comparing that to that list of important functions, and then naming it based on that. It has to do that several times so that it can get all the children capabilities and kind of bubble them up to the parents. So as this is running, let me also mention that I've already ran 2 other scripts. These are the 2 scripts that run on every file, and I mentioned that in that video, the Getting Started with Ghidra, and these are all on my GitHub page also. But I did the script to basically color target function instructions. So when I'm doing static analysis, I'm generally looking for calls, I'm looking for crypto operations, I'm looking for pointers, and I don't want to miss those, so I have a script that will color everything for me, or all the important instructions. And then also minimize the automatic function comments, because as I mentioned in the previous videos, all the functions get an automatic comment in Ghidra that basically just expand out your code blocks and make it a hassle to see. So I basically just replace all that with a single space. So we'll see what all that looks like. So we can see this ran, and we see in our functions window, we see we have these f_p, so we have them all renamed. Let me go ahead and sort this by name, and then we can kind of scroll through here and see. You can see we have some networking functions, registry functions, and you can see how they're file operations up here. So I'm going to start at the main. So I'm going to open up the graph view. I tend to do everything in the graph view so I can get these, read the assembly to look for YAR signatures, as well as easily see the code, like the code flow or the conditional logic, to get a sense of how it's working. So I need to go to the entry point. So actually, sorry, this is a DLL. I forgot it's a service DLL. So the DLL main is basically empty. So I'm going to go to the exports in this program's or symbol tree, and I see I have the service main. So I select that, and I go back to the graph view, and I'll give Ghidra a second to redraw the graph. So now that it's drawn, I'm going to basically just kind of flow down. In fact, let me save this now that I applied all the scripts. So I hit Control S. If you go back to the flat view, you can see a little save button got done. I'm only saving that right now because I'm going to do some naming, and then we'll probably actually start over to show you another methodology. So this is the way I tend to do my static analysis. I'll go through it iteratively. The first pass I'll get kind of like a table of contents overview, figure out where I want to look, and then I decide based on the table of contents overview where I want to dig down deeper. So I see I have a function here. It has calls because there's no ZC for 0 calls, but nothing of interest came up. I don't have any categories applied. So I'm going to skip over that. I see I'm setting up my service. I see I have a function with no calls inside it, 0 calls. Because I have this string copy here, my guess is that's doing some type of string manipulation, maybe like a string length or something, just from context. And then I have some function with a networking, registry, file stuff, process stuff, and you can see it goes on. And then I basically exit out with, again, a function with no calls. This looks like it's a utility function. It's called 88 times. I'm XORing the ECX with the EBP, which is probably a stack cookie. So this one's probably my stack cookie check. That means my main capability is really looks like inside this function because it has all the capabilities bubbled up to them. They're not in the current function because they're all lowercase. So I'm going to go ahead and hit L to label and call this main capability. Because if I'm starting to analyze this, I don't really care how the service gets set up. And so I really want to start the main capability. So I'm going to double click this and step into it. We'll give Ghidra a second to redraw. Alright, so now I'm going to scroll through again. So again, I see some functions, no categories I'm interested in, no calls, and then I basically end out, and I have this one more main capability because, again, I see all the different functionality, networking, registry, file stuff, process stuff, and it gets lost in there. And everything else in this function doesn't have any calls of interest to me. So it looks like we're just doing some setup, and then we're calling basically the inner main capability. So I'll hit L to label. Call this main capability inner. And again, I would prefer if this didn't let you duplicate names, I would just do the main capability like _0 like IDOPRO. But since Ghidra lets you duplicate names, I want to distinguish between the two. So I'm going to do it the inner, and I'll just double click this to step inside of it. So now immediately from the top, I see I'm reading a file. I know it's done inside this function because it's uppercase. And then I create a process. And then it looks like I go into this loop where I try to read a file again, and I sleep probably until I can read it. So my guess is I'm probably checking to see if a file is there. If not, I create a process. Maybe that process drops out a file, and then I wait until I can read it, until it's kind of dumped out. When it does, I'll come through exit over here. Now I see I have this function with no calls in it, or no calls of interest, but it has 26 cross-references. So it looks like a utility function. A lot of times I want to name the utility functions just to get a sense of what they are. So I'm going to go ahead and double click this and see what it is. Because the utility functions, I don't need to know exactly what they are, but they do add context. So just as soon as this opens up, I can tell this is called a RAN, a statically compiled library function. I'm not going to go into how to identify that because it's not the point of this video. So I'm going to go ahead and hit L to label and just call this RAN. And again, from context, I have a call to get to count, a function, and then call to RAN. So I know just from context, I can hit L to label, and this is SRAN. And that's what, a lot of times having these utility functions helps out with. So I basically build over some random numbers here. It looks like I'm writing a file, so this is probably, maybe dropping a file. And then I have some thread starts here. So I have a thread start here. I have another thread start here. Another thread start here. And then I do some file stuff here, some functions, no calls. I do something that looks like I read a registry key. And now I have a networking function where I build a socket, connect out, send, and receive. It looks like if that fails, I probably drop down to here, and then I loop around. And then I can see from my satellite view, it looks like I loop all the way back up to the top here. I will scroll up just so you can see it. We come back up to the top, read our file again, and try again. If that networking send and receive succeed, then I go into this function that has a lot of capabilities. I have networking, file stuff, process stuff in there. again, some of this goes from experience, some based on the script. So basically, I have some setup where I read some files, I come do some networking, I have a send receive. If that fails, I loop around, try again. Once I succeed, I go into a function that has a lot of capability. So if I had to guess, just knowing that this is a rat, this looks like it's probably network authentication, and this function looks like it's probably the command switch. Because basically, if you don't authenticate, you would basically send out maybe a challenge, a packet, get a response key back, compare it. If you fail, you'll loop around, try again. If you succeed, you come into your command switch. Let's double click this, what I think is a command switch, and see if we see a command switch. So if we look at the setup view here, this is how Ghidra draws a switch statement. So that tells us that I was pretty on track, that this is a command switch. So I'm going to go ahead and hit auto label and call this command switch. So now that I know it's likely a command switch, again, I have some 0 calls at the beginning here. I'm going to scroll through here. I see a network receive. Then I have a network send. And then I go into my switch. So my guess is this is probably the authentication. Maybe then I'm receiving a command code, maybe send back a response for it that we received it, and then we go into the switch statement. So I'm not going to analyze this whole file. I'm just going to show you, again, how you can get the table of contents overview with just a few minutes of scanning and a little bit of background knowledge of how malware is coded. So let's look at a couple of these commands just to see if we're looking for something specific, how easy it is to find it based just on the context. So just scrolling through here, I see everything has a network send, all in lowercase. So that probably tells me that all these capabilities have basically sending a response code back, probably a success or failure. So if I scroll back to the top, so let's look at this first one. So I have a file E, that means I'm enumerating a file, or enumerating the the file list. So that's probably something, if it's a command switch, I would think maybe getting like a directory listing. Here I have a file copy, and so it's probably just a copy file. So let's look at that. We'll just double click it, and we'll step inside and see what it looks like. Because this one's, I already looked at it, it's a pretty simple one. You can see where you're literally just copying a file, and then you probably send back your response code. But Alt left to get back. All right, let's scroll down a little more. It looks like I delete a file here. And then let's go ahead and look into it just so we can see. So again, copy file, delete file. Oftentimes when you program capabilities, program like capabilities together, it would make sense that if you just copy a file, another related capability would be delete a file. So I can scroll down here. I can see I open a handle, delete a file, and then I send back my probably response code. So let's kind of double click into here. So in fact, this looks like we either directly call delete file based on some argument, or we go into this one where we scroll, they're going to click into it. So in fact, before we go into it, let me go back for a second. Again, we're going from context. I have a capability where I either delete a file or I go into another function where I delete a file. So why would you have two functions inside an if-else statement with delete file? Probably because one's a delete file and one's a secure delete. Let's double click it and just see if our assumption is easily verifiable. So I have some function with no calls. I get file attributes. Set some file attributes. So I'm going to open a new file. So from create file, I know the fifth argument is the create disposition. I happen to know 3 is the create always. So I can hit, let's actually do the right click. And then we do set equate. And then this is going to be actually open existing. We do open existing. So, and then we'll double click it and it replace it. So we open existing file, get the file size. And then we write file. So why would you be writing to a file that you just opened to? Probably because you're overwriting it. We do that inside of a loop. We get random values here, so we're doing some ran. And we're just building out some strings, get the system directory. And then we delete the file at the end here. So the fact that it says delete here and then we're also writing it up here, and we have some rands. That kind of looks like delete, or like a secure delete, overriding it with random data, and then eventually deleting it. Again, we're looking just at the table of contents level here, the high overview. So I'm not going to be worried if I'm correct. I could label this if I want to. I could add to label and call this secure delete with a question mark, because I can come back and verify it. When I'm looking for indicators of compromise, first I need to get that kind of map of how the file is structured to figure out where I want to look. So if I want to know where you're doing secure deletes, or if you are, I would know to go back in here. So Alt left to get back. And if I want to, I could relabel this to label and call this delete or secure delete. Again, question mark. Next I have, so if I had a copy file, delete file, now I have, it looks like more file operations. So I have a file write and a file read. So probably it's going to be something like a put file and get file. And then I have another delete file. So this one is going to be a little bit different. We have not only delete, we have read and enumerate. So potentially we're searching for a target file to delete, or deleting a directory, something along those natures. But so again, we're not going to go through all these functions. I just want to give you an idea as we're scrolling through it. By having the capabilities, the preview of the capabilities, I can look at functions that are around each other and try to get an idea of what that function does. I can identify library functions just by the context, as we did with that rand and sran and the get tick count. You can see how easily this makes static analysis compared to if these were just all labeled as unknown functions. Not only, for instance, do I have to click into it, I know it has child functions, so I have to click through all the child functions, either try to label everything up, and it would take me literally a good amount of time to do that. Maybe, not forever, but it takes a while. The other way you do it is you look just for target indicators, you do cross-references. But I find that oftentimes if I just look for indicators and I jump around cross-references, I have no context of where I got there or what's going around it. And so I either get lost in library code, or I have none of that context to help me make educated guesses. And then it takes me significantly longer, rather than if I just spend an hour up front and go through and label at the high level like we did here, the basic functionality. And then I can either figure out where I want to dig into, or I can get that context of what's surrounding me to help me make these educated guesses what the capabilities are. So I'm going to go ahead and close this down. So that's kind of how this script works at the overview level. I want to show one more methodology. So I'm going to close it down, and I'm not going to save it because I don't want to save the renames. So that methodology where I go through the kind of table of contents level, I do that because I have enough experience. I've seen thousands of files, and so I can do a lot of it from educated guesses just based on knowing how different malware programs are programmed. But maybe you don't have that much experience, so you're still building it up, but you want to be able to use a script to find things quickly. So I want to show you the second methodology that you might want to use if you have less experience. Just like using like target APIs and finding cross references, you can do the same thing with the script. So again, I'm going to sort the name here. So let's say I want to find the capabilities first. I have a malware I think is a rat, and I want to find what the general capabilities are. So if it's a rat, it's probably going to have a command switch. Those command switches are usually identified by having a lot of functionality, because if you have 10, 20 different capabilities, you basically hit all the file stuff, network operations, processing, your registry, everything gets in there. So as I scroll through this function list, I'm basically looking for a function preview that has a lot of stuff in it. You can see here I have two that stand out. Just scrolling through here, so I basically pass my functions. You see I have two here that have networking stuff, registry stuff, file stuff, process stuff, thread stuff, and then cross-references. So my guess is it's one of those two. So it could be this first one, could be this second one. Let's select the first one. We click it, and then we'll open up the graph view. We'll see if it looks like a command switch. And they don't always have to be a switch, but as I scroll through here, I'm not seeing a lot of calls, so I see thread starts. So this doesn't really look like a command switch. They're not like if-else statements, there's not the actual switch statement. Let me go back and try the second one. So I click the second one, go back to the graph view, and we'll let it redraw the graph. All right, let's see if it redrew. Okay, so this drew. So this didn't look a command switch either, but it does have one more function in it that has a lot of stuff in it. Let's still go back to this other one, the functions view. So again, this third one down here, it's not as big as the first two, but you can see it has the networking stuff, file stuff, process stuff. The only thing it's missing is threads. So let's click that one. And really, you don't often have threads inside the command switch, so that would make a good reasoning. And we can see here is the command switch. So now I could label that L to label. So I go up to the top, hit L to label, and now I could call this command switch. So you can see that's a second way of finding that. Let's say I want to find my networking indicators. Maybe I tried to run this, and I didn't get any callouts, and I want to try to find out if it had networking stuff in it. So I'm going to look for networking operations. Let me scroll up through here. So if I want to find networking, I generally want to find the first time you connect out to the C2 server, and then I can find whatever the IP address or URL is and backtrack to see where it got derived from. So I'm looking for a network kind of either like a build and a connect. So I see, so I'm looking for uppercase because I want to find the place where the APIs are. So I have network and send, that's probably my send loop. I have a network receive, that's probably my receive loop. And then here we go, I have a networking, build, and connect out, and then modify. So probably like the HTONs in there. So I'm going to select that and go back to my graph view. And if I scroll through here, let's see what it looks like. So I have the NTOS, so I'm converting my endiness. I build a socket, and then I connect out. So this is probably the first time I connect out, and then I just have to figure out where it is. So I could find out which argument to connect has the IP address, backtrack it, and then I could go up to the top here, and I do the cross-references. So Control-Shift-F. There's only one cross-reference. I select the code unit to find out exactly where it's called, and then I can close that down. We'll let Ghidra redraw. So now that I went back to it, I could basically figure out which argument has the IP address for the connect, and then I could backtrack that to see, is it read from a configuration file, maybe one of those read files we saw in the beginning? Is it hard-coded in this binary? Is it randomly created like a domain generation algorithm? Something of that nature. That's kind of the other way I look for it. Same thing if I was looking for persistence. Maybe I'm looking for registry keys. So go back to my code browser, and then I'm going to look for registry stuff. So I'm not actually going to do this, but we'll just look here. So I see these have registries inside these big command switch ones. Go past these. So I'll have some file stuff here. Maybe put something in the startup directory. And so I don't really see any standalone registry operations. So they could be in a thread start. I could look at those. So I have here registry, where read a registry, read a registry. So I'm not seeing a write registry. So my suspicion is I wouldn't be writing to a run key. I think I'd be looking for the file writes and thinking that maybe it writes it in the like the startup folder. Now, obviously in this case, because we already know it's a service DLL, it's probably going to be inside of the service is probably an auto run. But if it's a different type of rat, not as a service, that would be the methodology you look at. So I hope that really shows how this script can help you do static analysis much quicker. It can really help you make educated guesses. And all it does is take a little bit to get used to the naming convention. And then you can really scroll through this and identify capabilities between educated guesses and your experience in really a matter of seconds. So oftentimes with the experience I have, if I get a new basic rat that doesn't have any abnormal capabilities, just a kind of standard rat, I can go mark up the kind of overview level within like an hour or two. It'll still take me a lot more time to drill into them and refine the names. But I'm looking just at the general capability of this reads a file, this calls out to networking, this authentication, the command switch. I can do that pretty quickly just based on these preview capabilities because I don't have to dig into hundreds of functions to find it. I can let the script look for all the important APIs for me and then just look at the surrounding context to make those educated guesses. So I hope you enjoyed the topic today. If you did, please like the video below and subscribe to my channel to get notified when new videos come out. I also love to know what you think about the video, so leave me comments. If you want more reverse engineering tips, follow me on Twitter. And if you're interested in structured training, check out my website for the malware analysis classes I offer. And until next time, keep on practicing and try to learn something new every day.